Yeah, good morning, students.
Good afternoon.
Yeah, good afternoon. Okay. So, right, I think yesterday I have given 2 questions. No? Have you solved that? What are the question numbers I have given yesterday, students?
Sir, 10 and 11, sir.
Page number
Sir, 874, sir.
874. Yeah. Is that done now or not? 10 and 11.
Sir, can you do 10th one, sir?
10th one.
Yes, sir.
Yeah. Okay, Nama. Okay, so shall we start all of you, students?
Yes, sir.
10th one, okay, I'm doing 10th one. I have written. Is there any doubts, students?
Sir, I have 10th one doubts.
Yeah, that's what. See that the what is the question number 10? If 1 gram of steam at 100 degrees centigrade is sent to 1 gram of ice at 0 degrees centigrade, the final condition of the system is. Final condition of the system means according to the option, it is clear that they are expecting that in the system how much amount of the steam will be there and how much amount of the water will be there, or else if possible, if it is there, then how much amount of the ice is there, that they are asking that. First of all, yesterday we have seen that till how long the heat will be transferred between the system of steam and system of ice means till that ice melts and ice water temperature is raised to 100 degrees centigrade. Till that instant, the heat will be flown from system of steam to system of this ice and ice water. First of all, what is the heat required to melt the ice and to raise the ice water temperature to 100 degrees centigrade? First, let us know. Right? So, heat required to melt ice and ice water temperature to ice water temperature to 100 degrees centigrade is 100 degrees centigrade is. Are you able to see this sentence? Heat
Yes, sir.
required to melt the ice and the ice water temperature to 100 degrees centigrade is first Q1. Let us take or else Q that is equals to. First, what is heat required to melt the ice means mass of ice and related heat of ice. This is the heat required to melt the ice. And this melted ice water temperature 100 degrees centigrade means initially this ice was at 0 degrees centigrade. That's why mass of ice and specific heat of water into delta theta of ice water. Okay. Delta theta of ice water. So this is the heat required to melt the ice as well as heat required to raise that melted ice water temperature to 100 degrees centigrade. So then I can write this is mass of ice is 1 gram, latent heat of ice is 80 plus mass of ice is again 1 gram. So just 1 gram of ice melts means 1 gram of water will be there. That's why mass of water, ice water is also 1 gram. Specific heat of water is 1. From where to where the temperature of this ice water is increasing. Ice water is initially at 0 degrees centigrade. Now it is increases to 100 means the rising temperature is 100 minus 0. So then I can write Q is equals to this 80 plus that 100, 180 calories. If only 180 calories of heat is enough to melt this 1 gram of ice and to raise that melted ice water temperature to 100 degrees centigrade. Right. Next, heat given out by 1 gram of steam. 1 gram of steam is 540 calories. We know that. So it means that what 1 gram of steam is converted into water. The heat given out is 540 calories. So observe this point very clear this moment. Hence, 540 calories of heat is given by liquefying 1 gram of steam. Okay. So to get 1 calorie of heat, then to get 1 calorie of heat is given by 1 by 540 gram of steam. Okay. 540 calories of heat is given out by converting 1 gram of steam into water. Hence, to get 540 calories, 1 gram of the steam has to be liquefied. So then to get 1 calorie of heat, so that to get 1 calorie of heat out, then 1 by 540 gram of steam is enough. So then we want 180 calories means to get 180 calories of heat, how much amount of the steam required? So therefore, steam required to get 180 calorie is so that implies for 1 calorie 1 by 540 gram means for 180 calorie that is 180 into 1 by 540 gram that implies how much 0 gets cancelled.
Sir, 180 by 3. 1 by 3.
1 by 3 gram only, isn't it or not?
Yes, sir.
So here, out of 1 gram, only 1/3 gram of the steam is converted into water. Remaining is here. So therefore, what is the final water in the system means water is okay. Water in system is so water means this 1 gram is melted.
Sir, but that side it's not visible, sir. Can I turn the camera?
Now it is okay.
Yes, sir.
Yeah. So water in system is already 1 gram of ice is melted and converted into water plus 1 by 3 gram of steam is converted into water means what is the final water of the system? This ice water 1 gram plus the
1
steam
plus 1 by 3.
1 by 3 that is 2 by 3 gram of water is there.
Sir, 4 by 3 grams, sir.
Huh?
4 by 3.
Yes, correct. 4 by 3 gram of water is there. Next, what is the steam in system means the steam in system is initially 1 gram of steam is there, out of that 1 by 3 is converted into water means the steam in the system is so 1 gram minus 1 by 3 that's equal to 2 by 3 gram. Finally, what was there in the system? 4 by 3 gram of water is there, 2 by 3 gram of steam is there. Both are at 100 degrees centigrade. That's why it is not possible to raise the temperature of this water and to melt this steam. That's why this will be uncondensed like that. Okay, this is very important. This one. This is okay, easy. Heat required to melt the ice at that melted ice water temperature to 100 degrees centigrade is this one. We want 180 calorie to melt the ice and to raise this melted ice water temperature to 100 degrees centigrade. Fine. So heat given out by 1 gram of steam is okay. What is the heat given out by 1 gram of steam means we know that 540 calorie. Hence 540 calorie of heat is given by 1 gram of steam. Okay, 540 calorie of heat is given by. Just a moment. Video is not clear, no?
No, sir. It's not clear. Audio and video are not syncing, sir.
Technical problem that is. Now, at least.
So sometimes it happens, sir. Sometimes it doesn't happen.
Yeah. So let us see, no problem. So right, heat given out by 1 gram of steam is 540 calorie. Hence, 540 calorie of heat is given by 1 gram of steam means to get 1 calorie, what is the steam required? 1 by 540 gram of steam is required. So to get 1 calorie of heat, 1 by 540 gram of steam is enough means to get it 180 calorie of heat, what is the steam required? Number of calories required in heat given out by 1 calorie for the steam, that is equals to 1 by 540 in 180, then you will get 1 by 2. Hence, out of 1 gram, only 1/3 of the gram of steam is enough for this. Rest of the 2/3 gram will be left as a steam only. That's why the final water in the system will be 1 plus 1 by 3, 4 by 3 gram water, and the steam that will be left, 2/3 is left there. Okay. So, right.
Sir, they have given first option is correct, sir. That is, they have given 4 by 3 grams and 1 by 3 grams of this one.
Yeah, 4 by 3 gram of water.
1 by 3 grams of steam they have given.
1 by 3, yeah.
Yes, sir.
Okay, add those 4 by 3 and 1 by 3. If you got 2 gram, that option is correct. If you are adding that, we are getting only 1 gram. No? Understand?
Sir?
If we add that 4 by 3 gram and 1 by 3 gram, how much you are getting? Only 1 gram.
5 by 3 we are getting, sir.
5 by 3 gram. But what is the total mass of the system? 2 gram. No?
Yes.
So then third option is if you add that, then?
Yes, sir. But they have given wrong. That's why I asked.
Third option is correct. Clear?
Clear, sir.
So, right. So next, the next question. Okay. 14th one, let us see on the 14th one. So today we will solve a few more problems and we will close. Tomorrow, next class, we will start with the thermal expansion. After that, solids will let us see. See that question number 14 once again, go through this question. So try to solve this question number 14 now. If not, then we will go through this explanation. Okay, so all of you try to solve the 14 right now. Okay, start doing the 14, question number 14. Is this copied, students?
Yes, sir.
Emma?
Yes, sir.
Yeah.
Yes, sir.
Yeah. So try to solve the question number 14 right now. Question number 14, what they have given first. The amount of heat required to convert 10 gram of ice at minus 10 degrees centigrade to steam at 100 degrees centigrade. Okay. So finally, we have ice at minus 10 degrees centigrade, and we need to convert that into steam at 100 degrees centigrade. So from here, the supplied heat is first. The supplied heat is used to raise the temperature of ice from minus 10 to 0 degrees. Okay, listen carefully this. The supplied heat is used to raise the ice temperature from minus 10 to 0 degrees. There onwards, the supplied heat is used to melt the 10 grams of ice at 0 degrees centigrade. There onwards, the supplied heat is used to raise that melted ice water temperature from 0 to 100. There onwards, the supplied heat is used to convert that 10 gram of water into steam. So that's why the supplied heat is 4 tasks are there. So till that 4 tasks are completed, we need to give the heat. How much amount of the heat we need to give to get completed the task which was given in the problem. First, some heat is enough, some heat is needed to raise the ice water temperature from minus 10 to 0. Next, some heat is used to melt the ice. Some part of the heat is used to raise that melted ice water temperature from 0 to 100 degrees centigrade. Next, last part of the heat is used to convert that water to steam at 100 degrees centigrade. Then the given task is completed. So to solve this problem, specific heat of ice is not given. Specific heat of ice is also a constant value. specific heat of ice that's equals to 0.5 calorie per gram centigrade. How we have remembered that specific heat of water is 1 calorie per gram centigrade. Similarly, specific heat of ice that's equals to 0.5 calorie per gram centigrade. So will you do it or we need to solve on the board? Students? Are you trying or what to do? If you wish, then we can solve it here itself. Students, please respond.
Sir, 1 minute, sir. We are doing.
Okay, right. So first. Okay, so let me write here. Heat required to raise ice temperature from 0 degrees and minus 10 degrees centigrade to 0 degrees centigrade. That is Q1 is equals to mass of ice into specific heat of ice into delta heat of ice. Okay, so that implies Q1 is equals to that implies Q1 equals to what is the mass of ice they have given 10 gram. Specific heat of ice is 0.5. Okay, and what is the rising temperature of ice means ice temperature is rising from minus 10 to 0. What is the rising temperature? That is nothing but 10 degrees. That's why we can write Q is equals to 50 calories. Hence 50 calories required to raise this ice temperature from minus 10 to 0 degrees centigrade. Next, heat required to melt the ice. To melt the ice. So therefore, Q2 that's equals to mass of ice into latent heat of ice. That's equals to mass of ice is 10 gram. They have given in the problem. Latent heat of ice is 80. This is a system calorie per gram. Here in calorie per gram gets cancelled. Then we will get 800 calories. 800 calories of heat is required to melt that ice. Next. Heat required to raise the ice water temperature from 0 degrees centigrade to 100 degrees centigrade. Q2 that's equals to mass of ice water or mass of water also you can take it no problem. Mass of water into specific heat of water into delta theta of this ice water. Water is obtained from by melting of ice. So that's why here how much amount of ice will melt, so the same amount of water will be there. That's why 10 gram specific heat of water is 1 calorie per gram centigrade. And delta theta is 100. So then we can write Q2 that's equals to I can write 1000 calories. Hence 1000 calories is required to raise this melted ice water temperature from 0 to 100 degrees centigrade. Next last one, heat required to convert into steam at 100 degrees centigrade is Q4 that's equals to mass of water, okay, or else mass into relation heat of steam, mass of water into relation heat of steam. Then we will get Q4, that's equals to 10 gram heat. For each gram, we have to supply 540 calories. That implies Q4, that's equals to 5400 calories. So initially, when we are starting, the system is at minus 10 degrees centigrade. At the end, we have the steam at 100 degrees centigrade. The given task is completed according to the problem, students.
Yes, sir.
Yeah, so what is the heat required? Here we have supplied 50 calories. Here we have supplied that implies Q2 is equals to 800 calories. Here we have supplied 1000 calories. Here we have supplied 540 calories. So then what is the total heat supplied? Total heat supplied. Okay, total heat supplied Q is equals to Q1 plus Q2 plus Q3 plus Q4. That implies Q is equal to add all these four. 50 plus 800, 850, 850 plus 1000, 1850, 1850 plus 5400. Total how much?
7,250.
7,000.
7250
calories.
yeah? Yes.
250.
That's equals to 7250 calories of heat is required. Okay. 7250 calorie of heat is required. Okay, have you got this, students?
Yes, sir.
Yes, sir.
Nice. So this is lengthy in the sense I have written step by step. Once if you are practiced, you can do the same thing in 3 steps. That's it. Okay, once it is. So till that instant, we need to improve our practice. Got it, students?
Yes, sir.
Yes.
Yes. Okay. So similarly, 16th one you try it. 17th one. So let us solve 17th one. Okay. 17th one. So please go through that question number 17 now. What they have given? A piece of ice, they have given a specific heat of ice, latent heat of ice in SI system of mass m grams is at minus 5 degrees centigrade at atmospheric pressure. Okay. It is given 420 joules of heat so that ice starts melting. Finally, when the ice and water mixture is in equilibrium, it is found that 1 gram of ice has melted. Assuming that there is no other heat exchange in the process, find the value of m. Okay, so please go through the questions. It is a bit confusing to understand. Once go through the question. Once go through the question. Okay, so students, first, so look at the problem. A piece of ice is there whose mass is don't know, okay, which is at minus 5 degrees centigrade. Now, heat of 4,200 joule. 4,200 joule is given to that system. Ice is starts melting. Finally, it is observed that 1 gram of ice is melted. Then, what is the initial mass of the system? Students, first have a look on it. Is that ice is directly melted, or before going to that anything happened across there? Is that ice is directly melted by absorbing that 420 joules?
No, sir.
No. So the reason is that by absorbing the 420 joules first, the entire ice temperature is raised from minus 5 degrees centigrade to 0 degrees centigrade. Then ice starts melting. So that 420 joules of energy is, was left by increasing the temperature of this entire m grams of ice from minus 5 to 0 and to melt 1 gram of ice. So then what is that they're asking me? So let us see that. So note down that point. The supplied heat is enough. Note down this point. The supplied heat is enough to raise the entire ice temperature from minus 5 degrees centigrade to 0 degrees centigrade, entire ice temperature from minus 5 degrees centigrade to 0 degrees centigrade, and to melt 1 gram of ice, to melt 1 gram of ice. That's it. So therefore, let m is the mass of ice. So then here supplied heat Q is equals to, so heat required to raise this ice water temperature means this mass of ice into specific heat of ice into delta theta of ice plus heat required to melt the ice means how much amount of the ice was made, 1 gram of ice. No? So therefore mass of so here okay, let us take here m1, here m2, relation heat of ice. So here you can take m1 is equal to capital M, which we are going to find. Here m2 is equal to mass of ice melts, that's equal to 1 gram. Observe clearly, all they have given in SI system means better to take this 1 gram is also in SI system. Then we will get 10 power minus 3 kg. Final answer will be, we will get in kgs. Then again we can convert easily into grams. So therefore, from this relation, what can I write? What is the heat supplied, students? Heat supplied.
420 joules.
Yeah, 420 is equals to this m1 equal to m mass of ice. We don't know. We need to calculate. Let it be. Specific heat of ice. They have given that water. 2100 joule per kg Kelvin. Substitute that 2100. What is the temperature rise of ice means? The temperature rise initially minus 5 to raise to 0. That's why we will get 5 degrees is the rising temperature. Okay. So, are you getting any doubt here? We need to take minus 5 like that. Any doubts are you getting?
No.
Yeah, so temperature is raised from minus 5 to degrees means the change in temperature is nothing but 5 degrees centigrade. Okay, that's why I wrote directly. Plus, what is the M2 means mass of ice that melt 1 gram, but here they have given L value in SI system. No, that's why I have converted this mass into SI system. Then I can write 10 power minus 3 in relation to heat of ice. They have given that 3.35, 3.36 into 10 to the power of 5. So then here 420 that's equals to, so then m of or else 2100 into 5 means then 10,500 only. 10,500. So plus here what is there 3.36 into 3.36 into 10 square will be get. So therefore that implies 420, that's equals to 10,500 m plus 336. So therefore 10,500 m, that's equals to 420 minus 336. Then m is equal to 420 minus 336 means how much?
84.
84 divided by 10,500. So this can be written as m is equals to 84 divided by 10.5 into 10 power minus 3 again, right? 84 by 10.5 means look at how much. I think 8 only, no, here it is 10.58 are nothing but
Yes, sir. 8.
Sir, 8, sir.
you can write 8 into 10, sorry, m is equals to 8 into 10 power minus 3 kg. So 10 power minus 3 kg can be written as 1 gram. That's why m is equals to
8 grams.
yes, 8 gram. So here all are level 2 problems, high standard problems in calorimetry. Simple thing one is they have given all. So let the mass of the ice they didn't given, but what they have given the hint by absorbing the 420 calories, ice temperature is raised from -5 to 0, and in addition to that, 1 gram of ice is absorbed to be melted. Then what is the initial mass of the temperature means the supplied heat is a part is used to raise this ice temperature from -5 to 0. Left the rest of the part is used to convert this ice into water. Like that, only 1 gram is converted into. So according to that, we have substituted, and this is nothing but 8 grams of initial. Got it, students? Any doubts you can ask them, students?
No doubt.
No doubt, sir.
Yes. Understood this problem?
Yes, sir.
Yeah. Okay. So 18th one to solve that we need to have an idea about thermodynamics. So let us see earlier. Okay. Okay, so next 20th, 21, next 23. Let us see these problems. So what is the question number 20th? So try to solve that 20th right now, students. Just you try to solve. If not getting, we'll discuss now. Okay. Will you try it right now, students?
Yes, sir.
Yeah. Okay. So other people also please respond. Those who are there apart from Abhay. Charan is there. Next, Meghana is there. Next, Nitur is there. Nandana, Nihar, Prajwal, Sanjay. Okay. So other people also please respond. Meghana, Nandan, Nihar, Prajwal, Sanjay. So try it. If not getting, let us see these problems.
Sir, can I do this on the board, sir? 20th.
Which one? 20th.
Yes, sir.
So right, what they have given, three different substances have their specific heats in the ratio of S1 is to S2 is to S3, that's equals to 2 is to 3 is to 1. So their increase in temperatures is in the ratio of 3 is to 2 is to 1. If the same heat is supplied, the ratio of their masses. So what they have given first, yeah. What they have given first. So therefore, the substances, the three substances have the specific heats. Specific heats. S1 is to S2 is to S3 is equals to. They have given that 3 is to 2 is to 1. That is 3 is to 2 is to 1. The 3 is to 2. Sorry, 2 is to 3 is to 1. So 2 is to 3 is to 1. Next, second one, the increase in temperature is nothing but delta theta 1 is to delta theta 2 is to delta theta 3, that's equals to what they are given. 3 is to 1 is to 2, that is 3 is to 1 is to 2. They have given the same quantity of heat, means dq1 is to dq2 is to dq3, that is equals to what we can write. 1 is to 1
1
is
is to
to 1. They are asking that ratio of masses. M1 is to M2 is to M3 is equals to. So first dq, that is equals to what can I write? Ms into d theta mu. So then m is equals to what can I write? M is equals to what can I write? M is equals to dq divided by s into d theta. Correct? So then m1 is to m2 is to m3 is equal to what can I write? dq1 divided by s1 into d theta 1 is to dq2 of s2 of d delta or else the both are same, no? Delta theta 2 is to, so then dq what can I write? dq 3 of s3, okay, is I can write delta theta. So here I can write this 2s is to 3s is to 1s can I write. 2 is to 3 is to 1 means 2s is to 3s is to 1s. So here I can write 3 theta is to 1 theta is to 2 theta. So theta is common, we can eliminate, s is common, we can eliminate, again we will get the same thing. Got it all of you?
Yes, sir.
So substitute this value. Anyway, dq1 is to dq2 is to dq3 means 1. By s1 means s1 is nothing but 2s. Okay. So and delta theta 1 means nothing but 3 theta is to, next 1 divided by s2 means 3s of delta theta 2 means 1 theta is here it is 1 divided by S3 means that is 1s of 1s of delta theta 3 means 2, which is common among this term. So in denominator S of theta is common among all the terms. We can eliminate that. Then we will get 1 by 6 is to 1 by 3 is to 1 by 2. So then this can be written as 1 is to 2 is to 3. That's it. Got it, all of you?
Sir, how this 1 by 6 is to 1 by 3 is to 1 by 2 can be written 1 into 2 is to 3.
You can multiply with 6 entire this relation. 6 by 6, 1, no? 6
Yes.
by 2, 2, 6 by 2, 3. Got it?
Okay, sir.
Okay, clear?
Yes, sir.
Clear, sir.
So simple according to this I have
Sir,
written.
Sir,
Yeah.
instead of taking that S and theta directly, we can do no, sir. Like we can take 1/6 is to 1/3.
No problem. You can take it. Doesn't mean that in place of S, so you can substitute 2 also. No problem. But in the ratio means what is that? They have given fractions only. Okay, that's why I have taken 2s is to 1s is to 3s is to 1s. So else you can substitute in place of s1 2, you can substitute s2 in place of 3, you can substitute. Both are same. dq1 is to dq2 is to dq3 means that is 1 is to 1 is to 1. No, that's why I have taken dq1 1 1. No problem, you can go for that also. Doesn't mean. Okay. So right, next one 22, 23. Okay, so 22. So next 24, 22, 23, 24, let us see. Nineteenth you try it, 19th that is simple. 21 also you can try it. Okay, so what the problem number I told right now, students? Either 21 or 22.
22.
Yeah. So look at the 22. So heat required to melt 1 gram of ice at 0 degrees centigrade is 80 calorie. A man choose 60 gram of ice and melt in 1 minute. It means that so a man is chewing 60 gram of ice means that 60 gram of ice is melted in the mouth of the man or not? Melted in the mouth of the man. So
It's
therefore,
melted.
heat is supplied from human body to ice. So therefore, how much amount of the heat is supplied means heat is supplied is enough to melt 60 gram of ice. 60 gram of ice. It was happened in 1 minute of time. Then what is mean by power? They are asking that. Still, what is mean by power means power is nothing but ratio of energy by time or work by time. Okay. So here the definition may be work power is not completed. The power can be defined as power P is equal to work divided by time. Work is nothing but energy. This can also be written as energy divided by time. So therefore, heat absorbed or heat gained by ice, Q is equals to just ice is melted means the heat gained that's equals to mass of ice melted into latent heat of ice. So therefore Q is equals to what is the mass of ice it was melted 60 gram, latent heat of ice that's equals to 80 gram. Therefore Q is equals to Q equal to what can I write? 4,000
4,800 calories.
calories. 4,800 calories. But in the options, if you have seen that power is in watt, means watt is an SI unit of power. That's why we need to convert this energy into joules because joule is an SI unit. Number 1 calorie is equal to what can I write? 4.2 joules. So that's why Q is equal to 4,800 into 4.2 joules. This was all happened in what time? So in a time of t is equals to 1 minute or 60 minutes.
1 minute.
So it was happened in a t is equals to 1 minute means how many seconds? That is t is equals to 80 seconds. Why I should convert t into 80 seconds? Why can't be
60 seconds, no, sir. 1 minute.
instead of 60 I wrote 80. 60 only. Why I should convert it into this 60 seconds means Second is the SI unit of time, not minute. That's why here joule here second. All are in SI units, then only the final unit also will be in SI system. That's why the power is equal according to that formula. Power P is equal to energy divided by time, means energy is nothing but heat. Heat is nothing but energy, Q by T. So therefore power P is equal to Q means 4800 into 4.2 divided by 60. So then you can calculate the power P. Power is in watt. So calculate how much it is.
336 watts, sir.
So that is 336 watt. So got it, guys. This is also different model. So first have a look on it. They have given heat required to melt 1 gram of ice. A man is eating a 60 gram of ice in 1 minute. What is his power means? So he is losing the heat which is enough to melt that 60 gram of ice in 1 minute. So hence he is giving the energy to the ice. He is giving the energy to the ice to melt in 1 minute. Hence continuously he energy is supplied from his body to the ice up to 1 minute. Then what is the power means? Power is nothing but energy per unit time, energy transferred per unit time. Or else in work per time is also, once if the work per energy chapter is completed, then you will know about the clarity between work and energy. Work is nothing but energy, energy is nothing but work. Without having an energy, it is not possible to do the work. If the work is done, means it can be stored into energy. Both are just vice and versa. Okay? So therefore, what is the heat gained? Heat is gained from where? From the man. So hence man is losing the heat and ice is gaining the heat. Heat gained by the ice to melt it means this much. This much energy is continuously supplied by the man for how many seconds? 60 seconds. Then what is the his power means? Power is nothing but energy by time. Energy is nothing but heat. That we got 360, 336 watt. Okay, so clear, students?
Clear, sir.
So right, next one. People answer. Earlier the students was 12 people, now it is 7. Why they are left in middle? So let us see the next problems. 23. Question number 23. The rest of the people, have you got this problem?
Yes, sir.
Yes, sir.
Yeah. Okay. So see that the problem. So 23, this is based on heating curve what we have discussed there. So observe clearly from the curve. A to B what will be happen, B to C what will be happen, C to D what will be happen, D to E what will be happen means A to B from the graph it is clear that A to B heat supplied is Q1. So that the temperature is rising from -20 to 0. B to C at constant temperature, one of the phase is changing, like ice is melting in water. So by that Q2 amount of the heat is absorbed by the system, and from C to D that melted ice water temperature is raised from 0 to 100. For that Q3 amount of the heat is absorbed, and D to E graph is a straight line. Hence, from D to E that water is converted into steam. That water is converted into steam. So then what they are asked to see that one. The following graph represents the change of state of 1 gram of ice at -20 degrees centigrade. Find the net heat required to convert into steam at 100 degrees centigrade. They have given that. So will you do it right now? This problem. So express the Q1 value, Q2 value, Q3 value, Q4 value, and add all of them Q1, Q2, Q3, Q4. Then we will get the net heat. Already this model we have done earlier, I think 3-4 numericals back. The net heat supplied, 4 steps I have written, and we have added all these energy supplied in these 4 steps. The same thing they have given in terms of graph. Have you understood the question, Amma, students?
Yes.
Yes, sir.
Yeah. So what is the Q1 value? So then directly I'm not writing any theoretical steps. So Q1 that's equals to what? Q1 is the heat required to raise this ice temperature from -20 to 0 degrees. It is from the graph it is clear. Q1 that's equals to mass of ice into the specific heat of ice into delta theta of ice. That's equals to mass of ice is 1 gram. Specific heat of ice they have given that 0.53. Okay, 0.53. The temperature raise means it is raised from -20 to 0 means 20. So then here I can write 5.15 20 means then I can write 10.6 correct?
Yes, sir.
Yeah, 10.6 calories. Q1 is heat supplied. It is clear from the graph. By absorbing Q1 amount of the heat, ice temperature is raised from -10 to 0 degrees centigrade. You can see on y-axis that is. And next from B to C, heat supplied is Q2. Q2 is the heat supplied at constant temperature 0, which is used to melt the ice. So therefore Q2 that's equals to what can I write? Mass of ice into relation heat of ice. That's equals to 1 into 80. That's equals to 80 calories. Only 1 gram of mass. That's all. Next, second one Q3. Q3 is the heat supplied between C and D. Between C and D, the ice water temperature is raised from 0 to 100. Then Q3 that's equals to mass of ice. Why I am writing mass of ice means if 1 gram of ice melts, then we will get only 1 gram of water. That is natural. We won't get 100 gram of water in unnatural manner. Okay, as you know that how much amount of ice will melt, that much amount of the water will be there in the system. 1 gram of ice is melt means so then 1 gram of water is there. That's why mass of water is also, or else let it be mass of water into specific heat of water into delta theta of water. What is mass of water means 1 specific heat of water is 1. Delta theta is nothing but 100. And we will get 600 calorie. Next, Q3 is Q4. Q4 is nothing but heat required to convert. So Q4 means D to E. So at D to E, at constant temperature 100 degrees centigrade, that water is converting into steam. So then I can write mass of water into relation heat of steam. I can write. So that implies Q4 that's equals to 1 in relation
540.
Yeah, 540. That's equals to 540 calories. Total Q1 value is 10.6, Q2 is 80 calorie, Q3 is 100 calorie, Q4 equal to 540. What is the total heat Q1 plus Q2 plus Q3?
729.6, sir.
6 calories.
How much? 7?
29.6 calories.
729.6.
Option is not there.
It's there, sir. First option.
First option.
Yes. I didn't see that. So the implied Q is equals to 729.6 calories. That is the heat which we have supplied. So all of the student, is this clear, Amma?
Yes, sir.
Clear.
Yeah. So last problem is there 24th. So by solving this last problem 24, we can close this topic called calorimetry. Then in the next class we will go with thermal expansion of the solids. So see that problem once again. So just a matter of 2-3 minutes. Okay. Okay. So can we solve that 24 now? Almost it is 1 o'clock.
Yes, sir.
Yeah, so right. So see the 24th one. A gas heater raises the temperature of 1 kg of water by 30 degrees centigrade in 10 minutes. How long will it take the same heater to raise the 3 kg of oil through the same rise of temperature if the specific heat of water is twice that of oil? So what they have given, first to use this relation. Okay, so use this. Let me write it. They have given that specific heat of water is 2 times that of the specific heat of water. W stands for water, O stands for oil. So, for example, this is the heater. Okay, this heater is first used to heat up the water. Second, it is used to heat up the oil. First, to heat up water. Okay, to heat up water, and here to heat up oil. Okay, so same heater is used means it will supply the heat to the water and to oil at constant manner or not in the same manner.
Yes,
Is
sir.
it true? So then rate of heat by this heater is constant. So therefore rate of heat by heater by heater is constant. So rate of heat means R is equals to dq by dt. So if dq amount of the heat is given by the heater in dt time interval, the rate of heat is dq by dt. So therefore, first here dq that is equals to mass of water into specific heat of water into delta theta of water. So here it was happened in what time? It was happened in theta that's equals to how many? In how many minutes water has heated? Water has heated in 10 minutes. In 10 minutes, that is okay. And here the changing temperature of water that's equals to I can write they are given 30 degrees centigrade. So then what is the rate of heat here? The rate of heat is nothing but dq by dt. That implies dq that's equals to mass of water into specific heat of water into delta theta of water divided by, so here dt that's equals to 10 minutes. Okay, so this is the rate of heat while it is supplied by the heater. Next, coming to the while to heat up oil, heat required that's equals to what? Mass of oil into specific heat of oil into delta theta of oil. So here in what, how many seconds means I don't know that. Here dt that's equals to, let us take some t time which we don't know theta. So here what can I write here? This is rate of heat in this case that's equals to again dq by dt. So here I will get m naught into specific heat of ice into delta theta of oil divided by dt means t that I. So here rate of heat is this one, here rate of heat is this one. As this oil and this water both are heated up by the same heater which supply the heat at constant rate. So therefore the rate of heat supplied by the heater while heating up of water is same as the rate of heat supplied by this oil while heating up of the oil, both are same. So therefore rate of heat is same, rate of heat is same. So then I can equate the rate of heat. So mass of water into specific heat of water into delta theta of water temperature divided by 10 is equals to mass of oil into specific heat of oil into delta theta of oil divided by T. So they are given that rising temperature is same for both the cases. Let's cancel it. So mass of water that is equals to what they have given mass of water
1 kg.
So then I can write one. Specific heat of water means specific heat of water can be replaced by 2 into specific
2
heat
into
of.
specific heat of oil.
So
By
2
the
into
specific heat of oil.
so divided by 10. Okay, that's equals to mass of oil is 3 and here specific heat of oil let it be SO divided by this SO gets cancelled. Then T is equals to so here 10 into 3 30 by 2 means that implies that T is equal to 15. So what is unit of T means here I have taken 10 in minutes now. Then I should get T is also in minutes. So that's what T is equals
15
to
minutes.
yeah 15 minutes. This is about the problem. Okay. So remember all of you what's Ask that who has raised the doubt. Some student is asking doubt. No, ask him what the doubt do you have? I noticed that one of the student has raised it to ask the doubts. Ask who is having a doubt, student.
Sir, I think by mistake. Yes.
Yeah. So no problem. Is this clear, guys? All of you?
Yes, sir.
Clear, sir.
Clear, sir.
Yes.
Any doubts are there, students?
No,
No,
sir.
sir.
So right, okay. So students, a few questions we left for your practice no, on this exercise. So I will try to solve those bits. If you have any doubts, please let me know it. We will try to solve those problems in further classes. So today it is this is till calorimetry we have completed objective also. So tomorrow in the next class we will see thermal expansion. Okay, clear, students?
Clear,
Clear.
sir.
Yeah.
Yes, sir.
Continue on next class. Okay.
Thank you,
sir.
sir.
Yeah.
Thank you, sir. Bye, sir.
Okay. Okay. Right. Bye.